Okay, hello everyone. Welcome again. Today we are going to look at methods used for solving linear programming problems, and I'm going to dwell with two methods. That is graphical method, and then we have simplex method. So I want to start with the graphical method, and it says this method involves using graphs to capture the visible areas and then using some other methods of inspection to get the best solution. So meaning if you have been given a linear programming problem and you are asked to find the optimal point, what you need to do, you can decide either to use simplex method or graphical method in order to make sure that you're able to get these optimal points. So when it comes to graphical method, we usually graph each constraint, and then after we have been able to plot those curves on the Cartesian plane, we pick the corner points, and then these corner points they give us the optimal pointer once we substitute them to the objective function. So today I want us to look at the steps that we usually use when it comes to solving linear programming problems using graphical method. And the first step, you need to graph each constraint. Assume you have been given a constraint that looks like this. Assume maybe like the kind of constraint that you have been given is, let's say, 3x1. You add 4x2 is less than or equal to 40. So having been given this constraint, what you need to do, you need to plot it on the Cartesian plane. That's what the procedure or the step number 1 says. And then from there, after you have been able to graph each constraint, you proceed to step number 2, which is shading the relevant zone. Because we want to get that relevant zone, what we need to do, we need to shade the unwanted region. Meaning, assume maybe like in the graph that maybe like we have been able to plot or to draw, and then maybe like this constraint, its curve appears that way. So because we are dealing with the less than or equal to, meaning any point that is above this line is supposed to be the unwanted region. So we don't want this region because we are dealing with less than or equal to 40. So meaning the points that fall below this 40, they are on this other side. Let us now go to step number 2. We have said we need to shade the relevant region, and that is the unwanted region. That is then the other point says that the combination of the two, maybe like you have first constraint and then you have the second constraint, and you are plotting them on a Cartesian plane. Where these 2 points will meet, you'll be able to see a clear picture of the wanted region or the relevant zone. That's what this point says, that the combination of the two will give you a region which is visible. The last step, which is step number 3, and is the most important one, it says use inspection to settle to settle on the base point, that is the optimum point. Meaning after we have been able now to plot maybe like let's say these are our graph, and you're using this particular graph to solve this the linear programming problem, and then you find that assume maybe like the other constraint, we have been able to plot it, and then it looks like this, and then you have been able to shade this as the unwanted region. So meaning this is the region that you are looking for. So what you need to do, point number 3 says we use the corner rule, i.e. the optimal point will be at the corner. So what you need to do for us to be able to get this optimal point, we take the corner points, meaning this is going to be our point number 1, or the first point. We can give it letter A. This is another corner, we can give it letter B, and this one is the last corner, we can give it letter C. That's how step number 3 says we use the corner rule, i.e. optimal point will be at the corner. Then from there we are told that we pick the coordinates of the corner points. So in this case, assume this is our graph, and this point A, obviously because it is the origin, the coordinates they're supposed to be 0, 0, meaning on the x-axis it is 0, on the y-axis it is still 0. At point B, let us assume maybe like this point it stands at let's say 10, but once you try to move upwards, you can be able to see that this point it is still at point 0. So the coordinates for point B, they're supposed to be 10, 0, and then the coordinates for point C, this is 0, and then going upwards, let's say maybe like this is 20. So meaning the coordinates for point C, they can be 0, 20. So these are the coordinates. We pick the coordinates of the corner points, and then we substitute these coordinates of the corner points to the objective function, and then we make a comparison, and then after making the comparison, we do the comparison, and then we make a decision. That is how we solve linear programming problem using graphical method. So these are the steps. The first step, you graph each constraint function, and then from there you shade the unwanted region. Then you proceed to point number 3, which says you use the inspection method to settle on the base point, that is the optimal point in this particular case. And then under point number 3, step 1, we use the corner rule to find the optimal point. And then you pick the coordinates of the corner points, and I've shown you how to pick the coordinates, and then from there you make the comparison. Okay, having done with the procedures or the steps that you use when it comes to solving linear programming problem using graphical method, now in our next video we are going to do it practically. So make sure you watch the next video and you subscribe for more updates. Thank you so much.